All right, how are we doing today? All right, so today we are going to be looking at simplifying algebraic expressions. Let's see. All right, so we're going to identify parts of an algebraic expression, and we're going to use distributive property to simplify algebraic expressions. So this first part says Sandra needs soccer shoes and socks. Shoes cost $45, a pair of white socks costs $5, and a pair of red socks costs $7.50. So we're to find the cost of one pair of shoes and two pair of white socks. Well, we know one pair of shoes is $45 plus $5 plus $5 is going to give me $55. Okay? And then it says if she buys two pairs of white socks and two pairs of red socks, what's the total cost? Well, we could say $5 plus $5 plus $7.50 plus $7.50, and that's going to give me $25. Now, we could also look at it as let X represent the number of pairs of socks she buys, write an expression to represent the cost of one pair of shoes, X pairs of white socks, and X pair of red socks. So we could say 45 plus $5 times however many socks plus 7.5 times X are how many socks. And by doing this, instead of adding everything, we can just put in the number of how many socks she wants and solve, okay? All right. So when we talk about an algebraic expression, there are parts of an algebraic expression. So when addition or subtraction signs separate an algebraic expression into parts, each part is a term. The numerical part of a term that contains a variable is called a coefficient of the variable. So for example, in 3x plus 7 plus x plus 2, these are all terms of the expression. So the expression has four terms: 3x, 7x, and 2. Okay? And then the coefficients are the number in front of the variable. So 3x, 3 would be the coefficient. X, remember there's an invisible 1 in front of there, so 1 is the coefficient. Okay? And in this chapter, we're only going to work with terms with the exponent of 1. So in this case, like terms are terms that contain the same variables, such as 2n and 5n, or 6xy and 4xy. A term without a variable is called a constant. So in this case, we have 5y and 2y. Those would be like terms. They have the same variable. And 3 would be a constant. It has no variable, so it's just a constant. All right. So it says to identify the like terms in the following expressions. 3x plus 4y plus 4x. Well, 3x and 4x have the same variable. So therefore, 3x and 4x are like terms. And then on B, we have 5x and 7x, and we have 3 and 4. So 5x and 7x are like terms since they have the same variables. And 3 and 4 are the same because they're both constants. They have no variable, so they're like terms. So this first thing says identify the like terms of the expression. Well, we have negative 4x and we have 2x. So negative 4x and 2x are like terms. And then we have 2y and 3y are like terms. So we had two sets of like terms in that problem. All right. So rewriting subtraction expressions using addition will help you identify the terms of expressions. So for example, it says to identify the terms, the like terms, the coefficients, and the constants in the expression 6x minus 2y plus x minus 5. So we're not solving anything, we're listing the parts of the expression. Now, to help you know where the signs go, I could change this to an addition problem. So where this says minus 2y and minus 5, I could change that to plus a negative 2y and plus a negative 5. So basically what I'm saying is the sign or the operation in front of the term goes with the term. So that minus 2y is really a negative 2y. That minus 5 is really a negative 5. So then, and don't forget, the x is really a 1x. So I would list the terms. I would list 6x, minus 2y, x, and minus 5. Those are my 4 terms from that expression. Now my like terms, I would list 6x and x. That's my only 2 like terms. Then my coefficients are the numbers in front of the variables or in front of the letters. So I have 6, negative 2, and 1. And then my constant is negative 5. That's the term without a variable. All right, so this next question says, identify the terms, like terms, coefficients, and constants in the expression. So I take a look at this, and I know that my terms would be 3n, 5m, negative 6m, and 2. Because I could rewrite that as 3n plus 5m plus negative 6m plus 2. Okay? So that's my terms. Now my like terms would be 5m and negative 6m. That would be my like terms. Okay? Now my coefficients would be 3, 5, and negative 6. Those are the numbers in front of the variables. And then lastly, my constants would simply just be 2. Now, you may come across a problem that doesn't have any like terms or doesn't have any constants. So sometimes it'll just be none, okay? But that's the ones for this problem. All right, so now we're talking about simplify algebraic expressions. An algebraic expression is in simplest form if it has no like terms, so you've combined all the like terms, and no parentheses. You've done any distributing that you need to. When you use distributive property to combine like terms, you are simplifying the expression. So this first example says simplify the expression. We have 4x plus 6 plus 2x. So if we needed to, we could use commutative property and put 4x plus 2x. So we put them together. And then we can add or distribute in reverse. We add the coefficients. So 4 plus 2 is 6. So that would be 6x plus 6. Okay? Now for B, we have 5n plus 2 minus n minus 6. Well, we could change that to an addition problem and put 5n plus 2 plus negative n plus negative 6. Don't forget that negative n is really negative 1n. Then we could use commutative property, and we could change these and put them in where like terms are together. We have 5n plus negative 1n, and we have 2 plus a negative 6. Then we simply combine the like terms. Excuse me. 5 plus a negative 1 is 4n, and then 2 plus a negative 6 is negative 4, so I'd simply write that as 4n minus 4. Okay? And then on C, it's a little bit different. We have 6y minus 3 times the difference of x and 2y. Now this is the one where we are going to distribute to each one, meaning we have to multiply the outside term times the inside terms. So we would have 6y plus negative 3 times x plus negative 2y. So we would take that negative 3 times x, and that gives me negative 3x. Then we would take the negative 3 times the negative 2 y, and that's going to give me positive 6y. And then I can combine my, or actually if you want to, you can use commutative property and rearrange and put all your like terms together. And that would give me 6y plus a negative 3x. 6y plus 6y is 6 plus 6 is 12, so that gives me 12y. And then I could simply just write that as 12y minus 3x. Okay? All right, pause the video, try these next three, and then come back. All right, welcome back. Let's see how you did. So if I change this around, I could say 4x plus negative 3x plus 6. And then this would be 4 plus a negative 3 x plus 6, or 1x plus 6, which I could simply just write x plus 6. Okay? And then on this one, I could change it around and say 2m plus a negative 7m plus 3 plus a negative 4. Let's see. 2 plus a negative 7 m plus 3 plus a negative 4. Let's see, this would be negative 5m plus 3 plus a negative 4 would be a negative 1. So I could say negative 5m minus 1. Okay? Now 3c, again, we have to distribute. So I would have 4 times q plus 4 times 8p plus p. So 4 times q would be 4q. 4 times 8 is 32p plus p. Remember, that's a 1 in front of the p. So 4q plus 32 plus 1 is 33p. And that's my answer. All right. So now we can look at a word problem. It says you have some money in a savings account. Your sister has $25 more than you have in her account. Write an expression in simplest form that represents the total amount of money in both accounts. Well, we know we have the amount of my money and we have the amount of your sister's money. We can let X be the amount of your money, and we can let X plus 25, since she has 25 more, be the sister's money. Now, if we want to know the total, we just add the two together. So that's where you would have X plus plus 25. We could regroup it and say X plus X, which would give me 2X, and then 2X plus 25. Okay? Let's look at that as an example for you to work. So we have Mato and Lola both collect stamps. Lola has 16 more stamps in her collection than Mato has. Write an expression in simplest form that represents the total number of stamps in both collections. Well, I can say Mato has X amount of stamps, and Lola has X plus 16, since it's 16 more stamps. And then I would simply say X plus 16. If I add those together, I'm going to get the total amount. So I could say X plus 16. And remember, the X's have a 1 in front of them. So that's 2X plus 16. And that would be my final answer. All right. If you got any questions, let me know. Otherwise, have a great day.